equation form the partial differential equation of all planes planes having equal intercepts having equal intercepts with from the x and y axis, having equal intercept from the x and y axis. Now they are asking that form the PD of all planes having equal intercepts from the x and y axis. Equation of a plane, equation of all planes having equal intercepts, having equal intercepts with x and y axis, with x and y axis is given by can anyone have idea about equation of all planes having equal intercepts with x and y axis?
X plus y equals to a.
Intercept form of the plane is x by a,
X by a plus y by b equals to 1, where a equal to b means equal.
a equal to b, both are same here. Therefore, is given by x by a plus y by a, both are same here, and z by b is equal to 1 here. Okay? You can get z by b is equal to 1. For this is the equation of all planes having equal intercept with x and y axis. Here. Now you have to differentiate this one partially with respect to a as usual. Now z is a function of x comma y. In that manner, you can think that. Differentiate equation number 1. Here a and b are arbitrary constants, where a and b are arbitrary constants. Therefore, you can eliminate arbitrary constant, then you can construct partial differential equations. You can construct partial differential equation. A and b are arbitrary constant. Differentiate one partially with respect to a. Differentiate one partially with respect to a. Sorry, with respect to x, not a. Differentiate partially with respect to x. Then what you can get here, x is 1, therefore 1 by a, y is 0, a is also 0 here, and plus z by b is there here. Therefore 1 by b, z with respect to x, we think that z is in terms of x and y. Therefore dou z by dou x, dou z by dou x is equal to 0. Dou z by dou x can be written as p here. Therefore 1 by b p equal to minus 1 by a, minus 1 by a. Or you can get it as p is equal to minus b by a, minus b by a. This is one relation. This is one relation, that idea you can get. Similarly, differentiate equation number 1. Differentiate equation number 1 partially with respect to y. Partially with respect to y. X by a 0 and y by a means you can get it as 1 by a. 1 by a. And then what you can get here 1 by b dou z by dou y, dou z by dou y equal to 0 here. 1 by b dou z by dou y is q is equal to minus 1 by a, no need to write p is equal to so on here, p is equal to so on, and minus 1 by a minus 1 by b relations you can get that. Therefore here no need of this expressions here, minus b by, or no problem here. Anyway, you can write same thing. P is equal to so on, and similarly you can get it as q is also minus b by a. Q is also minus b by a. We see that both the values are same. P equal to q. Therefore implies you can get p equal to q. Or p minus q is equal to 0 is the required partial differential equation. P minus q is equal to 0 is the required partial differential equation. Yeah, in this way you can construct a partial differential equation by eliminating arbitrary constants here. That idea we are getting. Now we have the another concept that formation of partial differential equation by eliminating arbitrary function. Arbitrary function, that is also another concept that we will see now here. Elimination of arbitrary constants, formation of partial differential equation by eliminating arbitrary function. Formation of partial differential equation by eliminating arbitrary. Yeah. Some problems based on this idea. Problem number one, form the partial differential equation from the following. Form the partial differential equation from the following. Problem number one is z equal to x square plus 2 times a function of 1 by y plus log x. Function of 1 by y plus log x. Function of 1 by y plus log x. 1 by y plus log x. You see that here this is the arbitrary function. The relationship may be function of 1 by y plus log x. Function of 1 by y plus log x. That function repeats some in the form of a square or a cube or combination. That function appears here. Therefore, that total relation can be written as a function of 1 by y log x. 1 by y log x here. That relation, that whole relation can be written like this here. Remaining things are x square plus 2f. Now we have to eliminate this function, this arbitrary function, and you have to get the partial differential equation. Here is also the same idea. What will be the given? Then differentiate partially with respect to x and y. You can get some idea here. Given z equal to x square plus 2 times a function of 1 by y, 1 by y plus log x. Differentiate this one partially with respect to x. Differentiate one partially with respect to x. With respect to x, what you can get, left side is p, right side is 2x, and then function derivative is whole thing derivative is f dash of 1 by y plus log x. Then inside function derivative with respect to x is 1 by x. 1 by x here. This is one relation. This is one relation you can get that. One relation you can get that. You have to eliminate this function. You have to eliminate this f here. F here. That will be the idea. You can get that. Now, similarly, this is one derivative. One derivative. Similarly, differentiate partially with respect to y. Similarly, differentiate equation number one partially with respect to y. Left side is q. Left side is q. Right side is with respect to y means 0, and the 2f dash, the same thing you can get that. The first whole derivative 1 by y plus log x. Then derivative with respect to y, you can get minus 1 by y square. Minus 1 by y square. This is derivative with respect to y. But we require a relationship between pq and x, y, and so on here. But you have to remove f. You have to remove f. That is the idea. Now you see that here from third last derivative, here f dash of this expression is there, and here is also f dash of this expression is there here. Therefore, from both the second and with respect to x derivative and with respect to y derivative, we have a function f dash is there here. Therefore, from both the expression, try to identify f dash, then equate f dash, then the problem is over. Here is also f dash. The letter is also you have f dash here. Therefore, identify f dash, what is f dash, then you can get some relation. So from equation number 2, f dash can be written as p minus 2x, p minus 2x into x by 2, x by 2 here. That idea you can get that. From equation number 2, f dash of 1 by y plus log x can be written as p minus 2x, p minus 2x
into x by 2.
into x by 2 into x by 2, x by 2, that expression again. Similarly, from 3, also f dash of 1 by y log x, dash of 1 by y log x can be written as uh,
Minus qy square by 2.
minus qy square by 2, minus qy square. Both are f dash here, therefore we can write that, we can equate these two. Implies p minus 2x into x by 2, that can be written as minus qy square by 2. 2 to get cancelled. Therefore, we can get the relationship as the xp minus 2x square plus qy square equal to 0. 0. This is the required partial differential equation. Ah, is the required partial differential equation. This is the required partial differential equation. This is the idea that you can get easily. Can get easily. Very simple procedure one. Just to differentiate partially with respect to x and partially with respect to y, partially with respect to x, partially with respect to y. Then you can get f dash, f dash, f dash, f dash, and then you can get p minus some relationship you can get for that f dash, a common derivative here. Then equate these two here. For all the problem, we can proceed easily in this way. That is the best idea to get the relationship. A similar manner, give the answer for this one here, second one. Z equal to f of x square plus y square plus z square. F of x square plus y square plus z square. Can you give the answer for this one? All of you. When differentiate partially with respect to x, f dash whole thing, but with respect to x means you can get 2x plus 2z p you can get. Okay? This is 0, 2z p. With respect to y means once again extra 2y plus 2z q. That's also you can get. F dash of whole thing. All of you try and give your answer for partial differential equation.
Sir, it should be need to be simplified more, or just I came with p by x plus zp equals to q by y plus 2 equation. Is it enough or more further
Enough, 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 enough. To differentiate partially with respect to x here, with respect to x means you can get p equal to f dash of x square plus y square plus z square into 2x plus 2zp. This is 1. With respect to y means q is equal to x square plus y square plus z square into 2y plus 2zq. From these f dash here, from 1 f dash can be f dash x square plus y square plus z square can be written as p by 2x plus 2zp. From 2, similarly from 2, f dash of x square plus y square plus z square can be written as q by 2y plus 2zq. Both are same. Therefore, you can get it as you have p by 2x plus 2zp equal to q by 2y plus 2zq. You can get 2y plus 2zq into p equal to 2x plus 2zp into p into q into q into q. Then expand. You write p and pq, that type of expression you can expand here. 2yp 2yp plus 2zpq 2zpq that is equal to 2xq 2zpq 2xq 2zpq plus 2zpq 2zpq. That 2zpq get cancelled here, therefore we can get it as 2yp 2yp minus 2xq or 2xq 2x. For your differential equation is p by x minus q by y equal to 0. P by x minus q by y. P by x, you can get right like this here. P by x minus q by y. Q by y equal to 0. Or any manner write that here. Xp py minus xq. Or you can also write that here. Py minus xq is equal to 0. Or you can write like this. Any manner you can write it. Py minus xq equal to 0 or py x minus q by y equal to 0. Any manner you can write the differential equation. This is the idea you can get that. Just to differentiate partially with respect to x and with respect to y, you can get f dash relationship. And equate f dash, both the f dash relationship, then you can get the required condition. You can get required condition. This is the idea you can get that. We have another problem that f of a relationship f of x square plus y square plus z square, comma lx plus my plus nz equal to 0. We have the relationship like this here. F of x square plus y square plus z square. F of x square plus y square plus z square. Lx plus my plus nez equal to 0 again. Lx plus my plus nez equal to 0. That type of relationship you have here. From this relationship, you have to get that the required partial differential equation. It means what here? Suppose f of relationship is f of ab equal to 0 means you can write a as a function of b. A as a function of b. F of ab equal to 0 means it may be a square minus b square equal to 0. A square minus b square equal to 0. Now you can write a as a function of b. A as a function of b here. For a square equal to b square, a equal to b, or a as some other function of b here, or it may be a cube or b cube here, a cube minus b cube. Not only this relation here, a can be written as b cube power 1 by 3 or a square or so on here, or you can write it as square root of so on here, square root of 3 by 2 here, 3 by 2, 3 by 2 you can get that here. Some relationship here, or you can write one thing as in terms of another relation, that type of idea you can get. For a function of a comma b equal to 0 means you can write one element as a one relation as a function of another one, in that idea you can use it. So in that manner, here you have a function of x square plus y square plus z square, comma so thing. Two things are present here. Therefore, this can be written as, from this you can write it as x square plus y square plus z square as a some other function of lx plus my plus nz. Some other function of lx plus my plus nz. Now relationship one arbitrary function you can get that one arbitrary function. Here pi is an arbitrary function. Pi is an arbitrary function. Now you have to differentiate this one partially with respect to x and partially with respect to y. Partially with respect to x and partially with respect to y. You can get some idea. You can get some idea. Like a previous problem here. Now differentiate one partially with respect to x. Partially with respect to x here, then 2x, y square is 0 and z is in terms of x and y, going to think like that only here. and it will be f dash pi dash of lx plus my plus nz, and the differentiation with respect to x means l plus n p of np. It is dou z by dou x, dou z by dou x of l plus np, and with respect to x this is 0 here. Pi dash is common here. Pi dash is common. So from this you can write pi dash of lx plus my plus, because we are going to proceed that way only, therefore you can immediately you can write like this here, l plus np, l plus np, and that you can get dou z by dou x. This is one equation. Similarly, differentiate one partially with respect to y. Okay? Partially with respect to y, what you can get here, 2y square, z square 2z, and 2z by dou y is q. Right side is pi dash of lx plus my plus nz, and then m plus nq. Partially with respect to y, my is m, and dou z by dou y, it is nq. Therefore, from this you can write pi dash of lx plus my plus nez. That can be written as 2y plus 2zq whole divided by m plus nq. M plus nq. This is third equation. Okay? This is third equation. Now both are same here. Okay? Both are same. Therefore, from equation number 2 and 3, we have, what do you have, 2x plus 2zb divided by l plus np. 2x plus 2zp L plus NP. Left side is 2y plus 2zq whole divided by m plus nq. 2x plus 2zp m plus nq, that is equal to 2y plus 2zq into L plus np. L plus np. Then I can club separate pq relations here. 2xm plus 2xnq plus 2zpm plus 2z 2zpqn, that is equal to 2yl 2ynp plus 2zql plus 2znpq, 2znpq, 2znpq get cancelled here, get cancelled here, and then you can club remain things p, you club p times and q times and so on here. Or if you club p times here, here p, and also 2 everywhere, 2, that's also get cancelled here. I can take commonly here. If you club p, then it will be zm, and here p 2 get cancelled, zm minus ny, minus ny. Then similarly q times, if you club like that here, q times, and here q x nx, nx, and zq, q time here, l is l is l is minus l is here, q time. Okay, this is get cancelled. This is remaining things are no pq involved here, and 2 also get cancelled here. Therefore, it will be ly minus mx. Ly minus mx. This is a required partial differential equation. P into mz minus ny, mz minus ny plus q into nx minus lz equal to ly minus mx is the required partial differential equation. Is the required partial differential equation. This is the idea you can get that. Okay? Right. think all of you understand how to get partial differential equation by eliminating
Yes, sir.
arbitrary function. Okay? Eliminating arbitrary function. Right. And now we give the answer for another one. Xy is equal to function of x plus y plus z. Xy is equal to function of x plus y plus z. All of you try and give your answer for this problem. Xy is equal to function of x plus y plus z.
Sir,
Mm.
px into y minus z,
Px into p into px
px into y minus z
into y minus z
plus qy into z
uh,
minus x
z minus x
plus z into y minus x.
z into y minus x
Yes, equal to 0.
equal to yes px into y minus z plus qy into z minus x plus z into y minus x equal to 0. Yes, very good. The good answer. Is all of you getting the same answer or not? Now all of you try for these problems here from the partial differential equation from the following. Number 1, z equal to ax plus, all are simple problem only, ax plus by plus ab. Second problem, a into x plus y plus b. Third problem, z equal to function of x square plus y square. And fourth problem, z equal to xy plus f of x square plus y square. Z equal to x into y plus f of x square plus y square plus z square. F of x square plus y square plus z square. Here a and b are arbitrary constants. A and b are arbitrary constants. Therefore, these are all by elimination arbitrary constants. A and b are arbitrary constants. Here eliminating arbitrary function. Arbitrary function. After completing the previous problem, all of you try these four problems. All are simple problems only. Simple problems. Form the partial differential equation from the following. Don't sit lazily without doing this problem, without solving these problems. All of you try. It will be experience for you only. All of you try. I will ask answers randomly. Yes, some of the people have left the meeting. Yes, can you give the answer for first one here? What will be the answer for the first one? Z equal to ax plus by plus ab.
Z equals to Px plus Qy plus Pq.
Very good. Z equal to px plus qy. Px plus qy plus pq. Very good. Second problem.
T minus Q equal to 0.
P minus q is equal to 0. Third one.
Py minus Qx is equal to 0.
Py minus qx is equal to 0. Fourth one over.
Fourth one, x square minus y square plus
X square minus y square
y into P minus zq.
p minus zq.
Sir, bracket only multiplied with y, sir.
Y
Not
only. Okay.
y.
Y x square minus y square plus y into
P minus zq.
uh, y is common.
Yes, sir, y is common.
Y into p minus zq.
Plus x into zp minus q. Plus x into bracket, sir. Zp
Uh,
minus q. Q is
zp.
equal to 0.
Okay. Right. Very good. Fantastic. Okay. These are all the answers based on by eliminating arbitrary constants and similarly as well as elimination of arbitrary functions. Arbitrary functions. Now Rahul only giving answers. Other people are doing or not. Please do whenever I give the problem for your exercise, then only it will be easy for you. Otherwise, it will be a cumulative effort you have to do. Okay. But this is the idea of elimination of arbitrary constant and elimination of arbitrary functions to form a partial differential equations. Right. Now further we move on to solution of partial differential equations. That is the idea we can move here. Solution of partial differential equations. The solution of partial differential equations. Some partial differential equations you can proceed by direct integration. Direct integration. If you proceed that, then you can easily get the solution here. For some other partial differential equation, it is not suitable here. The direct integration is not suitable. In that case, we have variety of solutions you can find here. That we are going to discuss one by one. Solution of partial differential equation. First thing you are going to see that here by direct integrations. Direct integration method. How to find a solution. That is somewhat easy only. To integrate one by one successively, then you can get the solution here. Direct integration procedure. The direct integration procedure just integrate successively, you can get respective solution here, respective condition here. First problem here, you take some simple problems here. Solve dou square z by dou x square, dou square z by dou x square plus dou square z by 2x square plus x is equal to 0 plus x equal to 0. Given that when x is equal to 0, z equal to e power y, z equal to e power y, and dou z by dou x is equal to 1. Dou z by dou x is equal to 1. Given that when x is equal to 0, z equal to e power y, and dou z by dou x is equal to 1. Dou z by dou x equal to 1. Now this will be the relationship you are having here. Given this is the partial differential equation you have here. Given dou square z by dou x square. Dou square z by dou x square equal to minus x. In that manner, you can think that. Now it is like a dou by dou x of dou z by dou x. Dou by dou x of dou z by dou x is equal to minus x. Dou by dou x of, you can write like this: dou by dou x of dou z by dou x is equal to minus x. Therefore, in order to remove this derivative with respect to x, you can integrate with respect to x. Integrate with respect to x, you can get some relationship. Similarly, here is also you can integrate with respect to x, you can get some other relationship. In that manner, you can proceed. Integrate both sides with respect to x here. With respect to x here, then what you can get here? You can get dou z by dou x, dou z by dou x. Dou z by dou x is equal to here minus 1. Dou z by dou x is equal to minus 1, or it may be dou z by dou x is equal to minus 1. Minus 1. That relation you can get here.
Sir, both sides integration no, sir.
Oh, sorry, integration. Sorry,
X square by
x square by, sorry. It will be minus x square by 2 plus a constant you can use here. A constant you can use here. A constant may be a or something. A or something. Indefinite integration you can use here. Here is it, so on. But partial derivative means you can use some other variable, but here z is purely depends on x. That type of relationship you can only are getting here. But because of partial derivative, we can use instead of a here, you can use some other function. Some other function f of y, or something. F of y. Some other function of y because of partial derivative. Instead of directly using a here, partial derivative you are using here. Partial integration also you can proceed here. Therefore, you can use f of y. And also one more thing is given here. If you want to find what will be f of y or something here, f of y or something, you can use the condition here. When x is equal to 0, when x is equal to 0, it is given that dou z by dou x is equal to 1. Dou z by dou x is equal to 1. That condition is given here. Whether it is y or something, that you can identify. Given that given that when x is equal to 0, we have dou z by dou x is equal to 1. Dou z by dou x is equal to 1. Dou z by dou x is equal to 1. For here you can use 0 here. 0. Substitute 0 here. X is equal to 0 here. It is totally 0. This is 1 only here. 1 only. Implies what you can get here. F of y is equal to 1 here. It is not a function of y. It is arbitrary constant only here. 1 constant only here. 1. Therefore, we have what we have here, dou z by dou x, dou z by dou x equal to minus x square by 2. Now f of y is 1. F of y is 1. Now again you have to get z here. Again you have to get z. Again integrate with respect to x. Again integrate with respect to x partially. Again integrate with respect to x partially here. With respect to x partially here is also. What you can get here z. This derivative get over z. With respect to x means x cube by 3 minus x cube by 6 here. X cube by 6 plus x. Plus x. Again you can use some other function of y here. G of y. G of y. Because partial derivative you are using here, you can use some other variable instead of constant, arbitrary constant. You can use some other variable instead of arbitrary constant for indefinite integration. For x cube by 6, here integration with respect to x is x, and g of y. For that thing you can do. Again, to identify g of y, we have the condition. X is equal to 0, z equal to e power y. Z equal to e power y, that condition is given. Z equal to e power y, that condition is given when x is equal to 0. For given that z equal to e power y when x is equal to 0, substitute in the above relation. Z equal to e power y, z equal to e power y, n x equal to 0. This is 0, this is 0. Therefore, g of y equal to e power y. Place e power y is equal to g of y. Therefore, the solution is z equal to minus x cube by 6, minus x cube by 6 plus x plus g of y is e power y. G of y is e power y. This will be the solution you can get. For based on the initial condition or boundary condition, here initial condition is given here when x is equal to 0. What about the z nature? Z equal to e power y, and dou z by dou x is equal to 1. Dou z by dou x equal to 1. Therefore, based on that idea, you can get respective conditions, respective integration. You can split into product of uh, split into derivatives with the chain derivatives here. And then in order to remove these derivatives here, integrate with respect to x and integrate with respect to x. Integrate with respect to x. Once again, you can get some relationship. But in order to get some arbitrary function here, arbitrary function instead of arbitrary constant here, we are going to use arbitrary function because of partial integration here. Partial integration. First one is f of y, second one is g of y. For f of, to identify f of y, you can use this one. G of y, you can use some other condition. In that manner, we can get that. In the same manner, you take one more problem here. Solve dou square z by dou x dou y. Dou square z by dou x dou y equal to sin x sin y. Dou square z by dou square z by dou x dou y. Dou square z by dou x dou y equal to sin x sin y. Here there is no initial condition is given here. There is no initial condition is given. Therefore, you have to treat arbitrary function as it is only. Arbitrary function as it is only. This can be written as dou by dou x of dou z by dou y. Dou z by dou y equal to sin x sin y. Integrate with respect to x partially and similarly integrate with respect to y partially, then you can get some relationship. Can you give the answer like a previous problem? But here there is no initial condition is given, therefore you have to keep arbitrary functions as it is only, not arbitrary constant, arbitrary functions. When you integrate with respect to x first here partially, this will be vanishes. You can get dou z by dou y equal to you can get cos x. Integration means minus cos x sin y plus partially with respect to x means you can get g of y. G of. Similarly, another one. Integrate with respect to y partially. Integrate with respect to y partially. You can get minus cos x minus cos y. Maybe f of y can be treated as g dash of y plus h of x. F of y integration is some other function, not g dash. It may be g of y, g of y plus h of x. Correct? What about your answer here? Is that equal to?
Z equals to cos x cos y plus g dash y plus f of x.
G of y plus f of h of x. F of y
G dash.
g dash.
G integral of g.
Integral of g is maybe h or something. Suppose you maybe put initially f of y, that integration will be g of y. initially put f of y, then integration will be g of y. Now h of x. After final derivative, it will be h of final integration. It will be h of g of y is integration of f of y. G of y is integration of f of y. Okay. Now, what type of partial differential equations can be solved by direct integration? You see that here in the first problem also, only one derivative is present here. So only one derivative, and the remaining things as a function here. And here is also only one derivative here. It's a product. It's a chain derivative is present here. It is also a chain derivative is present that you can use. Suppose if you have a derivative like this here, dou z by dou x plus dou square z by dou y square. Dou square z by dou y square equal to e power y something. E power y something. But if you have the derivative like this here, partial equation PD is like this here, partial differential equation like this here. If you integrate here with respect to x here, it is okay. But here with respect to x means it is somewhat of typical here because it is addition of expression. Okay? Addition of expression, a linear combination of derivative is possible. Linear combination of derivative. It's not depends on only one derivative. Okay? Only one derivative. The previous problems are depends on only one derivative here. Therefore, you proceeded the chain integration, chain rule of integration, you get a solution. But if you have the partial differential equation like this here, a linear combination of derivatives here, then direct integration is somewhat difficult here. Direct integration is somewhat difficult. We cannot proceed by this way. Cannot proceed by this way. For this purpose, we are going to consider